Yes, all right. You're most welcome, dear viewers. Thank you very much for moving with me always. You always welcome you by telling you that, please, if you're a new person, don't forget to subscribe because if you don't subscribe, you'll always be missing the updates. So be able to subscribe such that you can be able to follow. At this particular moment, I want to tell you that you're most welcome for this new concept here. You might have heard about it. For clarification, let us follow it. Send me a WhatsApp message 0758876705 or else call. I'll be able to receive. You've got the comment section right there, something that you want to ask, I'll be able to respond to it. Send me an email, dixocastan07@gmail.com. Still, I'll be able to respond to it. At this particular moment, allow us to look at this one. Here we are looking at the magnitude of a complex number. It can be called magnitude or else it can be called length of a complex number. It can also be called the modulus of a complex number. They all mean the same thing. Why do we call it magnitude? Why do we call it length? Or why do we call it modulus? In one case, we call it modulus of a complex number, but why do we call it length still? We shall go into details and see. Let us assume we have a complex number Z. Assuming that we have a complex number Z, for us to be able to get this length of a complex number or modulus of a complex number, we shall use what we are calling a Cartesian diagram in this case. Yes, let us use the Cartesian plane. We draw there something as we shall be knowing solid by solid. Let us first begin by Cartesian. Let us first begin with the Cartesian plane. If this is x-axis and this is y-axis, we have two axes there. We have a Cartesian plane. Now, when we are in complex numbers, the x-axis will be our real axis, and then the y-axis will become our imaginary axis in the Cartesian plane. And when we write it like this is our real axis, and then this is our imaginary axis. Now, when you write it like that, it will no longer be a Cartesian plane. It is now a complex plane. Take note of that. It is no longer a Cartesian plane, but it is now a complex plane with the real axis and the imaginary axis. But it is just a duplicate of the Cartesian plane. Now, we shall plot our complex number. If we have the complex number z equals x plus y in Cartesian, so in coordinate form, we shall write it as x, y. In coordinate form. So we have the x, the value of x, and we also have the value of y. This point here can be plotted. You come and plot. That's the point we have plotted x, y, and when you reach them, the complex number itself is denoted by a straight line up the point, and then with an arrow. You use an arrow, you note that. Now from there, this is the complex number we are talking about, z. Now, from here up to here is x, from here up to here is y. That case. Now, what is the length of our complex number? The length of our complex number is from here up to here. The one we are calling magnitude, and at the same time we are calling it modulus. This length here from here to here. And how do we denote it? How do you denote magnitude of something? So, to denote magnitude, if this one is Z, which in this case, let us call this length from here up to here R. Just call it R. That length from there up there, we are calling it R, meaning that. So let us use pictograph theory because this one here is at 90. And you see what we are talking? We are applying pictograph theorem. When you apply pictograph theorem, what do we do? X squared plus y squared equal to R squared. So R will be equal to square root of x squared plus y squared. So we are having square root of x squared plus y squared as R. And what is R? R is our range from here, the range of the complex number, the one we are calling modulus, and at the same time we are calling it magnitude of the complex number. So in that case, how do we denote the modulus of the complex number? The modulus of the complex number Z is denoted by what? Is denoted by Z magnitude. That's the modulus of the complex number. Is denoted by Z magnitude. And for this case, we are saying that this Z magnitude is equal to what? To R. And R which is x squared plus y squared and a root. So, finally, we are saying that the modulus of the complex number is always equal to y squared, x squared plus y squared in the root. The answer you get will always be on units. We shall just put the word units because this is relative. We don't know which units we are here, so we just put what? Units. That's what we are talking about in that case. That's modulus of the complex number. So we are getting it through this what? This is the way how it is denoted, and we are coming up with that. For example, let us give an example. Find the modulus of each of the following. Now we are saying that point number 1 can have 0 plus, let us just have 4i, point number 2 plus 4i, point number 3, point number 4, 3 minus 4i, that case. So, you can look at this and see, can you be able to get the modulus of each complex number which is here? Let us see. Number 1, which is 4i solution, let us let this be equal to that. Now, if we let it be equal to that, what does it mean? If we want to get modulus, it is x squared plus y squared in the root. That's the formula that we will use, and we are according to what we have obtained. So Z magnitude will be equal to our x is, we have plus 0 there. So our x is 0 and our y is 4. So x which is 0 squared plus y is 4 squared. So Z magnitude will be equal to, this is 4 square root. So Z magnitude is equal to 4 units. Is equal to 4 units in that case. Let us look at the scenario. Roman number 2. You can also look at this one, you can be able to get it. This one, let us look at Roman number 3 and see. Roman number 3. So our rate might Z is equal to 3. I know that magnitude of Z, or modulus of Z is equal to x squared plus y squared in the root. So Z magnitude is equal to this is plus 0i. 3 plus 0i. So we are saying that this is 3 squared plus 0 squared. So I'm having Z magnitude, which is 3 square root, and I'm getting 3. So Z magnitude remains 3 units. So if you purely real, the resultant answer will be the same. Will just remain that complex number for the magnitude in that case. Let it be purely imaginary, also the resultant answer will remain the same as that one. The value of the imaginary part of the complex number. That's what we are talking about in that case. At this particular moment, you can now, I strongly believe each and every one who has solved this can be able to get the modulus of each and every complex number that can be given to you. Let it be a conjugate. Someone can go ahead and ask you the modulus of a conjugate of a certain complex number. So that one will be denoted by Z bar magnitude. I see that. That's the modulus of the conjugate of the complex number. So you need to be able to get the modulus of the conjugate first before you can be able to get the modulus of the conjugate. Simple as that. We follow step by step, not until we reach the point that we are interested in. At this particular moment, allow me to wish you the best for this particular case. I always want to tell you that don't forget to subscribe, like, share. Send me a message on 0758876705. You can pass via WhatsApp or else you can call. I'll be able to respond. Any email on dixocarson07@gmail.com. I'll be able to get. At this particular moment, don't miss the next step. The next step will all be about get the argument of the complex number. Don't miss. I wish you the best.